Good morning, guys. Today we are going to begin the second section of first chapter, that is measurement and measuring instrument. Last class we finished the class with rules and conventions for writing SI units and their symbols. And this class we are going to begin with vernier caliper and screw gauge. In our daily life, we usually use this measuring scale, which is calibrated in centimeter and millimeter. The least amount of the smallest value of a measuring scale is 1 mm. That much accuracy only we can measure from a measuring scale. But if suppose we are having even more smaller object or some other irregular structure, we need a specific instrument for measure those things. For that purpose, we are having instruments like vernier caliper and screw gauge. First, we are going to begin with vernier caliper. If you see vernier caliper, we are provided with some extra data that is about the scientist who found the vernier caliper. His name is Pierre Verny. He lived between 1580s to 1637. He was a French government official and he learned maths and science from his father, who was worked as a lawyer and an engineer. He spent his life as an engineer most of the time, and also he did cartography and surviving. Um, while taking surveys, he needs special instruments. For that purpose only, he innovated this vernier caliper. Now we are coming into the vernier caliper instrument. So now I think you can see the vernier caliper instrument clearly. So in this instrument you can see a scale. This scale is called as a main scale. This main scale is calibrated in millimeter and centimeter. On the left side edge of the main scale, we are having a set of jaws. One jaw in the top, one jaw in the bottom. Those two jaws were fixed jaws. On the right side of the fixed jaws, we are having another set of jaws, one on the top and one on the bottom, over a slider. This slider is provided with a screw. With the help of the screw, we can fix this slider anywhere in the main scale. And also at the back of the slider, it is provided with a rod. When we are moving the slider to the right side of the main scale, this rod will poke out from the vernier scale. With the help of that rod, we can measure the depth of the objects. And this slider will also have a scale, and this scale is called as vernier scale. And what is the function of this jaws? The upper jaws were used to measure the internal dimensions of object, and the bottom jaw, they are used to measure the external dimensions of objects. Now, usage of vernier caliper. If we take usage of vernier caliper, we have to first find the least count, range and zero error of the vernier caliper. Now we are coming to least count. What is the least count? Least count means LC, it is equal to the smallest value of the main scale division by total number of divisions in the vernier scale. That is least count. If you take the smallest value of the main scale, it is 1 mm, and the vernier scale is having 10 divisions. So 1 mm by 10, it is giving 0.1 mm. It is equal to 0.01 centimeter. Next one, zero error. So talking about zero error, uh, the vernier scale is also having a 0 and the main scale is also having a 0. When you are moving the slider to the left side end, this slider, when you are moving the slider to the left side end and both the jaws are touching each other, and if the vernier scale 0 and the main scale 0 or coincides with each other, then that means there is no zero error. If suppose like this, if the here in this picture, the bottom one is the vernier scale division, the top one is the main scale division. Okay, so in this case, KCA, take KCA. In this, the vernier scale 0 is little bit on the right side of the main scale 0. That means it is positive error. That means the value what we obtained from this vernier caliber, it is not the true value. We are having little bit extra value. That extra value we have to reduce so that we will get the true value. So now we have to find the zero error, positive zero error for that. How to find the positive zero error? Now we have to go to the vernier scale and we have to find which division of the vernier scale is coincide with the main scale. If you look into the picture, you can find number 5, fifth line is coincide with the main scale division. That means 5 is the extra. Okay, so positive zero error will be 5 into 0.01 into least count 0.01, it will give you 0.05 centimeter, and this is the positive error. That means 0.05 centimeter is excess in the value. We have to reduce it. So how to reduce it? We have to minus the 0.05 centimeter from the obtained value to get the true value. Now coming to the negative zero error. Here if you see the picture B, you can see that vernier scale 0 is little bit left on the main scale 0. That means the value what we obtained is little bit less than the true value, exact value. So what we have to do, we have to find the negative error and we have to correct it. How to correct it? We have to add it. So here if you check which division is coincide, from the left side if you check, you can find the sixth division is coincide with the main scale. So when you are calculating the negative zero error, you should not calculate from the right side. You should not count from the left side to right side. You have to count from right side to left side. So from if you count right side to left, the sixth division will become fourth division. Okay, so 4 is the error. What you have to do? This 4 into LC minus 4 into 0.01, it is giving minus 0.04 centimeter. Okay, so this is the value which we are not having. Okay, so now we have to add this 0.04 centimeter with the obtained value to get the true value. So this is the usage of vernier caliber. We are provided with other 3 more cases also. We will look into it and you will get clear with this cases and you will understand the vernier caliber much better. Case 1 if you take, they are telling that the vernier scale 0 and main scale 0 are coincide with each other. That means there is no zero error. The value what we obtained is the right value and it is a true value. Now case B. If you take case B, they are telling that it is having a positive error. The 0 is on the right side of the main scale 0 and 8th division is coincide with the vernier scale division. 8th vernier scale division is coincide with the main scale division. So now the error will be 8 plus 8. So to find the positive error, plus 8 into LC, that is 0.01 centimeter, it will give you 0.08 centimeter. So this 0.08 centimeter is excess. This 0.08 centimeter we have to deduct so that we will get the true value. So there is an application of problem here. I will explain that and you will understand it much better. And case 3. If you take case 3, 0 of vernier scale, it is now on the left side of the main scale 0. That means it is negative error. And they are telling that 4th division of vernier scale is coincide with the main scale. So for the negative error, you have to count the divisions from the right to left. If you count from right to left, the 4th division will become 6th division. So the error will be minus 6 into LC, that is a 0.1 centimeter. You will get minus 0.06 centimeter. This much less value you are having. So you have to add this 0.06 minus 0.06 centimeter along with the obtained value to get the true value. Here we are having a problem. So in this problem, they had given us the main scale reading is 8 centimeter and the vernier coincidence is 4 and the positive error is 0.05 centimeter. So now we will do the math. So we are provided with the main scale reading. We will write the main scale reading as 8 centimeter plus, okay, and we are given with the vernier scale coincidence, that is 4 plus 4 into least count 0.01 centimeter, okay, and we are having a positive 0 error. They already calculate another positive 0 error, that as 0.05 centimeter. So now how it will become 8 plus, we did the multiplication, so it becomes 0.04 minus 0.05, so it becomes like that. So now if you do the math, this 0.05, 0.04, it goes out and we are getting minus 0.01. So from 8 you have to deduct 0.01 and the value you obtained is the true value, that is 7.99 centimeter. Same way they did another math which with negative 0 error. So here also we are having the main scale reading as 8 centimeter and vernier coincidence is 4, negative 0 error is 2 centimeter, 0.02 centimeter. So we are going to do the math. 8 plus 4 into 0.01 centimeter plus, because negative 0 error we have to add, plus 0.02 centimeter. When you sum up everything, you are getting the value 8.06 centimeter. I think now you have understood the vernier caliber much better. And next one is the digital vernier caliber. If you see the digital vernier caliber, I told you about a rod which pokes out, no? So here you can see a rod on the right side of the vernier scale, right side of the main scale. A small rod is poking out, that is the rod used to measure the depth, okay. So this digital vernier caliber, it is provided with a digital display in the slider, okay. There is no need for us to calculate the manual calculation. This display itself, it will show what is the accurate value is. Next one, screw cage. If we take screw cage, with the vernier caliber we can measure up to 0.01 centimeter, but with the help of the screw cage we can measure up to 1/100th part of a millimeter, that is 0.01 mm. Up to that level we can measure accurately. So let us see what is a screw cage, parts of screw cage. So if you see, if you look into the screw cage, this is the picture of screw cage. It is having a U-shaped structure. On the left side of the U-shape top, we are having a fixed stud. It is noted as anvil, and at the right side of the U-shape we are having a movable stud. It is called a spindle. Okay, this movable stud spindle is connected with the head scale and ratchet. When you are going to rotate the head scale and ratchet, the spindle will move forward and backward according to the clockwise and anti-clockwise movement respectively. And over this spindle we are having a cylindrical body. The cylindrical body is calibrated with a pitch scale. Okay, over the pitch scale we are having another cylinder, and in that cylinder we are having a taper structure. Over that taper structure it is having 100 divisions of calibration. This scale is called as head scale. Okay, that's it. These are the parts of screw cage. At the end we are having the ratchet to fix the objects between the fixed stud and the movable stud. Now we will look into the usage of the screw cage. If you see the usage of screw cage, it works on the principle that how many if you are going to screw that spindle, if you are going to screw that spindle, how much distance it move forward, that is directly proportional to the number of rotation of the head scale. Okay, that is the principle. And the pitch, now pitch of the screw, pitch of the screw is working according to the principle what I told you now. One pitch, it is equal to the one pitch level is that much distance the spindle is moving with one rotation of the head scale. That is one pitch. You understand now? And next one, least count. If you take least count, LC, it is equal to the smallest pitch scale reading by total number of head scale division. The smallest pitch scale reading is 1 mm and head scale divisions is 100, so 1 by 100 we are getting 0.01 mm. That much accurate value we will get. And next one, it is zero error. What is a zero error? So now this pitch scale is also having a 0 and head scale is also having a 0. After removing the head scale and moving the spindle and touching the stud, left side fixed stud, now if you check, if the 0 of the pitch scale and head scale coincide with each other, then there is no zero error. If suppose the 0 of the head scale is little bit below the pitch scale axis, then it is called as positive error. Now we have to check which division of the head scale is coincide with the pitch scale axis. Number 5, fifth division is coincide with the pitch scale axis. So the error is 5. Okay. Now we have to calculate the positive zero error. So 5 into the least count 0.01, it is equal to 0.05 mm. So how we will correct? Now we have, if we are having positive error means we are having some excess value. So the value what we obtained from positive error, we have to minus it in the obtained value to get the true value. So we are going to minus 0.05 mm in the obtained value to get the true value. If suppose the 0 of the head scale is going to be on the top above the pitch scale axis, then again we have to check for which division is coincide with the pitch scale axis. Now here number 95, it is division 95 is coincide with the pitch scale axis. Okay, that means the error is minus 5. Okay, how we will find that error? So minus 100 minus 95 into LC. So minus 100 minus 95 we are getting minus 5 into LC is 0.01, we are getting minus 0.05 mm. So the zero error is minus 0.05 mm. How we will correct the negative error? We have to add the negative error value with the obtained value to get the accurate and true value. So this is the working of screw cage, and here we are having a procedure to measure the thickness of the coin. So before measuring the thickness of the coin, we have to find the pitch of the scale, least count, zero error of the screw cage, and then we have to place the coin in between the two studs, that fixed stud and movable spindle. Between those things we have to fix it with the help of the rotation of the ratchet and the head scale. Okay, ratchet and head scale are fixed together. Okay, after a limit only the ratchet will rotate separately. Okay, so now by rotating the ratchet, you can fix the coin in between the fixed stud and movable stud firmly but not tightly. Okay, it should not fall down, that much only you have to give the tightness. And then you have to measure the pitch scale reading and then head scale coincidence. After measuring those things, you have to do the head scale correction. That is, the if you are having any errors, positive error or negative error, you have to correct it. No? So after correcting everything, you have to add the PSR, that is pitch scale reading, and this corrected value head scale reading, and you will get the thickness of the coin. You have to repeat this procedure 3 or 4 times to get the accurate value of that thickness of the coin. And next topic we are having measuring mass. Before measuring mass, we are having a do you know box. In the do you know box, it is talking about eggshell. Eggshell is 12% of the mass of the egg, and blue whale is weighs as 30 elephants, and it is long as 3 tourist buses. Okay, now we are coming back to the measuring of mass. So measuring of mass, we are having plenty of equipments. First we are beginning with beam balance. So from the word itself we can understand, with the help of the beam, balance is used to measure the weight of the object. So you can see a center a beam is there. So over the beam there is a balance with 2 plates. Okay, so using this beam balance, we can measure from 5 grams to 5 kg of weight. And then next one is two pan balance. This type of two pan balance we can easily see in the grocery shops. Okay, nowadays most of them are having digital weighing machine, but little earlier, and still some few shops are having this two plate balance. With the help of this two plate balance, we can measure up to 5 grams, 5 grams, even 5 grams, up to the capacity of the machine we can measure. Next one, physical balance. This type of physical balance you might have seen in the labs, and even in banks you might have seen for measuring the gold ornaments, jewelries. When you are going to get the jewel loan, you might have seen this instrument. So this is very sensitive, that is why it is placed inside the glass box. And with the help of this physical balance, we can measure from 10 grams itself, from 10 grams to, sorry, 10 milligrams to 200 grams, milligrams, 10 milligrams to 200 grams, so we can measure. And next one, it is the digital balance. Most of the digital balance we nowadays it is present everywhere, even the grocery shop, even the jewelry shop, everywhere we can find this digital displays. We can measure the lowest value as 10 grams and the highest value according to the capacity of the machine. The next one, it is spring balance. If you look into the spring balance, it is having a spring connected to a hook, and this hook is attached with a scale, with a pointer, with a scale, with a graduation and a pointer. Okay, so when you are going to add the weight on the hook side, the spring is going to elongate. When the spring is going to elongate, the pointer in the measuring scale, it will show the reading of the uh, object which is attached to that spring. That is, that pointer will show how much weight that object is. Okay, so this is how the spring balance is working. And next one, difference between mass and weight. Mass, what is a mass? Quantity of matter contained in a body. Weight, so if you see weight, weight is the force given by the surface against the body, against the gravitational pull. Okay, we are attached to the surface because of the gravitational pull. When we are giving a force, the surface will offer a opposite force. There is equal and opposite reaction for every action, no? So according to the Newton's third law, so the same. So when the gravitational pull is working on our body, the surface will give back some force to the body. That force is called as the weight. Okay, so to make it clear, we are given a problem, and a man of a mass of 50 kg on earth, what will be his weight? So when you are measuring the weight, we have to use the formula mg. M is the mass and g is the acceleration due to gravity. So acceleration due to gravity will be 9.8. Mass they already gave. So 50 into 9.8, we are getting 490 Newton of force. And next one, I distinguish between mass and a difference between mass and weight. First one, for mass it is a fundamental quantity. Weight it is a derived quantity. And if you take mass, mass is a scalar quantity. Why scalar quantity? Scalar quantities will have magnitude alone. It won't have direction. Mass will have how much the mass is, how much kg the mass is. It won't have the direction. But weight, it is a vector quantity. It will have magnitude, that is the force value. Above we saw 490 Newton, no? That 490 Newton force, the magnitude will be there, and the direction. So this force is offered from the surface to the body, so it is having a direction. So weight is a vector quantity. Now definition for mass. Mass is the amount of matter contained in a body. Weight is the force extended by the surface against the gravitational pull. This mass is going to be same everywhere. If you are going to measure it in earth or moon or anywhere else, the mass is not going to change at all. But this weight will vary according to the gravitational pull of that place. We are given an example in the bottom. I'll show you. And the next point, it is measured using balance. Mass is measured using physical balance. Weight is measured using spring balance. So in spring balance, we are just putting the object over the hook, so it is hanging on the top. So here gravitational pull is acting over it. So we are using this spring balance to measure the weight. Okay. The unit of mass is kilogram. The unit of weight is Newton. I told you we are provided with an example. Now I am continuing the example. If you consider the earth gravitation, it is acceleration due to gravity is 9.8. The same with the moon. If you check, the value will be 1.63 meters per second square. That is almost 1/6 of the value of the earth. So if a man weighs 70 kg in earth, his weight will be 686 Newton in earth. If you calculate for moon, it will be around 114 Newton. How? 70 into 1.63. You will get 114 Newton of value. Next one, it is accuracy in measurement. What is accuracy in measurement? Accuracy is very much important in every field of engineering, physics and all kind of science. Because if we are going to a jewelry shop, without accuracy we cannot pay the money for the gold what we are purchasing. And they cannot also sell the gold material. If suppose take cooking, if there is no proper measurement, if the salt is going to be little bit higher, we won't be able to eat. So accuracy is very important. But faulty instrument and human errors can lead to inaccurate values. For that we have to constantly check the value of that correctness of that instrument, and then we have to repeat the experiment 3 or 4 times, and we have to average the value to get the accurate value. That's it, guys. The first chapter of physics is over. If you have any doubt, you just text me. I'll try to clear it. Thank you, guys.